What's up guys, this is Alessio from the Dev Experience here at Snap Spectacles. Today I want to deep dive into connected lenses. This is a topic that is very important for the spectacles ecosystem. It's something that definitely is not too easy at first. There are a lot of concepts that needs to be absorbed and integrated for you to succeed. Also myself included, I deep dived into this topic not too long ago, so I hope that my learnings are going to be also very helpful for you because I don't come from such a big expert background about this topic particularly, but it's something I picked up. Everything is very different from Unity, so I hope that my perspective allows you also to understand a lot more about this. So let's get into it right away. I want to start really from the documentation to just get a grasp of very basic concept. And then I'm going to explain you what I'm going to do, what is going to be this project that I'm going to also share with you. So don't worry about getting crazy by following up 100% this video. Everything I do is going to be shared with you and you will have the time that you want just to go through it. Also, what I recommend sometimes is just like drag and drop all of these scripts to ChatGPT or any IDE Copilot editor of your preference and try really to map and understand what's going on here. This was very helpful for me. I think I understood very easily and fast how those connected lenses samples that we find in our repository are made. So this is going to be very helpful for you. Repository and show you what I'm going to talk about today. So first of all, you're going to find samples about connected lenses here in this section in our repo. These are also accessible through the Lens Studio homepage. Here there are different flavors of the same technology, basically, that is connected lenses and multiplayer. Then another thing that you should do if you look into connected lenses is really started from this overview that you find on the documentation pages. So what are connected lenses and why do they call it connected? Well, it's pretty self-explanatory. It's, as you know, applications for the spectacle ecosystem is called lenses because they originated from the Snapchat app. And the connected lenses are really applications that you can play together in the same space. So the main difference between general multiplayer application is really understanding that you need to be collocated. In fact, this is one of the first things that you realize going through the documentation. This experience is spectacle to spectacles in this case, because we are, of course, talking about spectacles development. And here you will see that these lenses are collocated. So we're playing multiplayer, but in the same space. These are synchronous lenses, so meaning that it's not an asynchronous based process, meaning that there are constant calls, so everything in real time, and this allows you to keep everything in the loop and very stably. There is a certain architecture that comes with connected lenses. I feel like the most shared thing the most helpful thing about this documentation will be found more in the spectacle sync kit, which is the sync that powers the connected lenses. Here, it just tells you really pretty much how things work. You're going to be scanning your space around you. Then you're going to choose if you want to do a session that is single player or multiplayer. In the case you're doing multiplayer session, you will see in the proximity who's available and you're going to start the session yourself, or you're going to join the session that someone else started, and then you should be able to see the other person in the same space and everything will make sense in terms of shared virtual content. Another thing is that when you do that, there is also a process of alignment. So there will be some virtual glasses that will point to the direction that you or your collocated friends will need to position and just look at the same direction just to center and just basically start the session in the same local space accurately. In connected lenses, as I mentioned, it requires something called Spectacle Sync Kit. This sync kit is one of the kits that you need to know if you want to develop with spectacles. As you can see here, there are the framework section. We have the spectacle interaction kit, the sync kit, and the navigation kit, so on. Really, I will try also to summarize the information and let you start really with something that it's going to work for you. And I'm not going to go through everything. It's going to be more of a reverse engineering tutorial just to show you what's possible and then going back. But just a little bit of a basic understanding, I feel it would be really helpful. Also, before I forget, I want to mention an incredible tutorial from LensFest by one of my coworkers, Laura. She explains everything here, particularly she goes through the build-up of the tic-tac-toe sample that you also find here in the GitHub repository. She goes through everything. She explained all of the basic concept very accurately, everything you need to know, and she also live coded all of the applications. So you will see, I hope that you find the time just to go through this tutorial. It's not too visual. As you can see, the screens are a little bit far, but if you really listen carefully to what she says, you really have a good understanding of what's going on. And the name of the tutorial is Building Shared Experience and it's part of LensFest or the Snappy YouTube channel. So let's going back on the getting started for the Spectacle Sync Kit. I would say that probably the most important concept are these three. So the session controller is the first, let's say, element that you need to know. And it's basically a main manager of all of this technology stack. It's everything that you need just to set it up. So it's very much the first element that goes into the loop. And without that, of course, you cannot do anything. So the great recommendation, like big recommendations for the way to work with this technology is that always wait for certain states to be ready before you do something. Otherwise, something doesn't work. Actually, I helped a developer just a week ago that was having a problem about connected lenses. His code was flawless. The only thing is that the order of the calls was slightly different, so things were not actually working. So the order of all of these things makes sense because you need to enable object before to synchronize the object, right? Because it's all about synchronizing things. So we can think of the session controller as the game master, knows who's playing and manage the multiplayer session. Then we can think of the SyncEntity as sharing device, or makes the object shareable across all of the devices. So remember very well this concept because we're gonna go through another diagram and we're gonna remap this concept in that diagram. So session controller manager basically put everything together. SyncEntity is pretty much an object which is synced across all of the devices. So if that object has this component that is called SyncEntity, meaning that you're gonna sync something about this object. The most common sync entity is the sync transform because you're syncing the position, the scale, and the rotation of object in space. And then we have the storage properties, which is syncing again, but it's storage. So you're just storing data and you're syncing across all of the things. So before going ahead and just like going to explore any other concept, remember manager, syncing, and storing. These three things are the basics for understanding how connected lenses work. Also another mind-bending concept that you feel, and this tutorial is for everyone, again, so it's not just for people that are super expert about this topic, so I keep it very back and forth between very basic concept and very advanced concepts. Another thing you must know is that when you are dealing with connected lenses or multiplayer technology generally, there is not a real common space, right? A common space is just the cloud that transfers information from one player to the other one. What is happening instead is that you have instantiation, so you have the same object locally for you, the same object locally for someone else, and these two objects act as the same. So they are informed by the same data that are on the cloud. So this is very important to understand because you might think, oh, there is just one object visually, but it's not how it works. You are basically only syncing entities, and these entities could be any kind. Could be positions, could be data. Most common one are usually position, rotation, and because you have in games or application, you have things that need to move, but you might also have data. For example, you want to store all of the data for one player, and those data are going to affect all of the other players. So that is a storage property because you need to store it somewhere and then you need to retrieve it. Another thing that is not mentioned here. So another thing that I want to mention is the concept of ownership. The concept of ownership is very helpful in the scenarios because when two entities are shared across multiple apps. For example, there is my app, your friend's app, and we all have a session that is running. Then in all of these three apps, we see a cube that is rotating. That information is shared across all of our devices, right? But the ownership of that cube needs to be defined because who's spinning that cube? That's the main question that you need to ask yourself every time. If it's something that someone else is streaming to everyone else, and if something that you're doing in that object because is your object or was another person's object. So this is a little bit mind-bending for generally multiplayer. I think you might think, oh, I got it. But then you just develop and you actually you fall into this trap every time. You just need to think about things that you don't need to think about connected lenses as a shared experience in a way, but you need to think about it more as a synced experience, if that can help. So let's go through here and we see more visually what is happening, which is mapping, session controller, instantiator, and SyncEntity. Indeed, when you're trying to start an application that is a connected lens, you're gonna map before. So you locate your ground, you locate your session. Then after that, you're going to start the session controller, which is the main engine that starts everything. Then eventually, if you have something that instantiates different pieces or different things, you're going to use something called Instantiator, and then you will have the in the initialization of all of these entities that is being instantiated. Once again, key building blocks, session controller, let's repeat it again, manager of everything. Then we have an instantiator, which is an intermediary between when the session starts and all the sync entity needs to be instantiated. And then we have the sync entity, of course, after the instantiator. And then we have the storage properties, which are, again, sync entities as data across different sessions. Once again, more than connected lens is a sync lens. So put that in your mind if you're trying to understand very basic and the very basics of connected lenses. Then we have a very helpful deep dive of all of the things that you can do right in connected lenses. And more than going through one by one of this concept, I think would be very helpful to just take a look at the project that we're going through. So call me a millennial or whatever, but I think that there's no better way to explain connected lenses if not taking a look at something like this. In fact, today we're gonna build Kamehameha lens. And why are we doing this? Because, believe it or not, Dragon Ball, this Dragon Ball lens allows you to understand how to reference hands of the other player. I'm gonna also add the head pose of the other player. So you're gonna have hands and then you're gonna have head of the other player as a reference. Not only that, but we're also gonna create a line between us and the other player. So there is almost like shared reference across ourselves that we can both visualize. And we're also gonna do some cool calculation, which is finding the midpoints between me and you. So we can have things that are positioned that there and the position makes sense in relation of our positions. This is also a lens that you can scale in many other things. For example, get rid of that line Kamehameha concept. You might just find the middle point between me and you to instantiate your first sync entities, for example. Sometimes something very common across multiplayer application is that me or you, we are in the same space and I'm like, hey, can you see that? And there is never, it's rare to see things perfectly at the first time. Actually, this allows you to have things between me and you perfectly and have a starting point for your application to work with. The first thing that I wanted to show is really the lens, how it works. I'm not just wasting your time. Actually, this lens is already ready for you and we're just gonna go through how it works and how you can make it too. As you can see in this video, we're syncing our position whenever we cross our hands because the distance of the hands, and I'm just gonna stop and share what's going on. When the distance of our ends is going to be less than 20 centimeters, Kamehameha is in position, so is ready. Meaning that a metric 3D line is going to be generated and updated between me and Shin, and in the middle of it, there is going to be a sphere to signify the middle point. Just imagine adding more particles and more specific to the game. I like to think of this tutorial as a part 1 because I would like to develop it more. But also I don't want to get to the perfection. I just want to share with you things and just keep improving them and maybe sharing them again. And I hope that you would take this template, the samples, and make something crazy out of it. So as you can see in this video, the distance between my hands goes below 20 centimeters. So now Kamehameha is ready. And when both of us have it ready, you will see that there is a perfect synchronization, which is there is a little bit of a lerp, which I added between my real position and the position of the starting point. You can see how accurate it is. And also you can see that we have the position of the head pose with a little bit of an offset. And you can see that we have the position of myself, hands, and Shin's hands. So to build it, to just connect with a line to people. So let's get into the project, right? Now we know what we are signing up for. I hope that this introduction gives you a little bit of an understanding of how things work. And now let's see what, as a developer, would be your experience into Lens Studio. So if you go into this project, which I will share, and as you can see, there is High Five because I actually started this project from one of our samples called High Five, which was the only connected lens that would give me a share point between my hand and the other player hand. So really that was my first approach to try to understand how things would work. And then I evolved from there to understand, so you can actually reference the two ends of the two player and so on. I applied the same thing to the head pose and also big shout out to Laura and Mitchell that helped me so much in this tutorial and really speeded up things to make me finish all of this in 2 days, otherwise would never be possible. So I really wanted to understand this thing in depth so I could do this for you. And so let's get into it. As you can see in this project, you see that there are three main folders. One is called Beam, one is called Hands, and one is called Player. So if we open them, you notice that there is a similar pattern between all of these folders, which is a manager and a controller. This is a very helpful pattern to understand and very repeatable and very scalable. So pay attention how things work here, because this is going to be very helpful as you can really apply to everything you want to do. If we go in the Kamehameha manager, we have 4 objects. We have the Instantiator, and then we have 3 different manager. Once again, one for the player, one for the hand, and one for the line or energy beam. The player, I wrote player, but basically player is your head pose. So we are sharing the position of the head pose. Hand object manager, share the position of your hands. And energy beam manager is the manager that care about instantiating the references for the line to be interpreted from me and from you in our local space. Instantiator is the script that we also looked up in our documentation previously. So if we go back in our documentation, you see here the instantiator instantiate prefabs across the network. So this allows you to just, if you don't know what is instantiation, by the way, it's really just like spawning an object in space. So in this case, that's the first step that we need to take care of just in this, actually not the first step. The first step is make sure that we have a spectacle scene kit. So let me restart from this scene hierarchy. So let's go to the scene hierarchy. The scene hierarchy has a prefab that is the spectacle scene kit. If you go into our packages, you notice that we imported the spectacle scene kit. The spectacle scene kit is something that you can find here. If you don't start from samples that we just provide to our repository or homepage, it's something that you find here. And this one has probably a prefab folder. Actually, the prefab is here. This is the only one you need. And you just drag and drop it into the scene. And this is it. The scene kit needs the spectacle interaction kit, of course, to have things that are working together, to understand inputs, to understand me, to understand you. Not necessarily, but especially in this template, it needs it. So we have, let's put aside for a second the spectacle interaction kit, which is something that you always need in your lenses if you want to have input interaction. We have the spectacle sync kit here. First thing you find, once again, session controller is the main manager that does everything for you under the hood, so it's already set up for you. Hidden from scene view, you have something called enable on awake. On the unawake space, and this is just a very good practice, is like to have a parent where you put all of your objects under it and you just have things that just turns on when it's awake. So you're just doing basically this, you're just enabling. Then we have something which is actually very interesting here, and it's called Collocated World. Collocated World has something that is very helpful and very crucial. Why? Because it allows you to enable things on ready. And as we mentioned in the previous part of the tutorial, it's very important that you don't do things before they aren't ready, because things are not going to work, it's going to throw you error. So you want to have your session ready for instantiating things. So what we have on enable on ready, let's take a look in here. We have an entity target, we have network group. This is all to be set up for you automatically. You shouldn't be doing this, but I would just show you because it's something that you might not be familiar. So in the collocated world, by the way, this will be the space where all of the shared synced entities will be captured across session. So that's your local space between you and other players in your lens. Then we go in the Kamehameha manager is basically our edits. So this is really where our lens starts. And we have something called Instantiator, and we have something called player object manager. We have something called hand object manager, energy beam manager. Once again, we go back in here in our assets. There is beam, hands, and player. Once again here, player, let's put it in the same order so we don't confuse. Let's go also, actually it's called beam, so let's keep it that way. So we have beam, hand, and player. This is the line, this is the hand, and this is the head pose. And then there is an instantiator. The instantiator is something that also you don't need to, is something that is already available for you and it's part of the sync kit. And this instantiator that is part of the sync kit already knows that it's not going to be alive if there is not a session that is actually existing. Otherwise, it's not going to be there. And this is, you don't need to make any instantiator. So once again, I was wrong. The lens that you're actually going to do is these 3 objects here. And then we're going to see how this works. And this is more like the part where you put your creativity into it and understand how to do things. And even here, this is a very solid pattern that you will see also in Laura's tutorials. And that allows you really to scale your lens and do a lot of things in this way. Let's go in the energy beam manager, hand object manager, and player object manager. Actually, I like more this order because I feel like it goes from the easier to the more complex. Let's take a look at the player object manager that has a reference to the instantiator and then has a player object prefab, which in our case is just a queue. So if we select on this, let's see where it leads us. Let's open up this prefab here, which is called player object. This player object has a parent that is an empty game object, but has attached a sync transform and a player object controller. So we had a manager in our scene, and then we have a controller which is attached on our prefab that we will instantiate. And this prefab also has something called sync transform, which is basically just a sub order of the sync entity, but it's just very specific for transforms. As we mentioned before, sync entities is just something that I see and then you see, but some properties about this object are synced across our sessions. So if, just to make it a lot more simple for you, and sorry if I'm repeating again, but I want you to understand that, let's say that my cube is positioned 0, 1, 2, those 0, 1, 2 is going to go on the cloud and then go back to the session of my friend, and his cube, which looks similar to mine because we are basically deploying the same application, is going to have the same position. Then it's up to our rules. So what we want to be able to say, hey, is the object yours? Because if it's mine, it's going to be this color. If it's yours, it's going to be that color, so on. So this is the player object in prefab, and has as a child just a very normal cube, so a flat material cube, which is the orange one that we show later. The sync transform is going to have, you probably don't need to change anything here besides something called interpolation target, which is just nothing but the lerp speed or the lerp update, because whenever this information are streamed across the cloud, of course, it's not particularly instantaneous, so it's always recommended to have a little bit of lag. That's a pretty common thing to see in multiplayer video games. Of course, the better the game is, the less is the lag. Really depends what you have to do. In this case, 0.25 for what I'm doing, it's okay, but if you want to reduce it, you're just gonna go and say 0.1 and see if it works great for you, for what you have to do. It also depends from the connectivity quality. Then we have the player object controller, which is, once again, pair, controller and manager. So let's go back in the scene. Player object manager, reference to instantiator, reference to player object. But take a look at the instantiator. The instantiator also have these prefabs here, which is the same that I have in the player object prefab. So the instantiator is the utility that actually handles all of the object that we will see in common. So if this object is not going to be on the instantiator, my couple manager controller won't work. So just so this is exposed, you can do things also in different ways. But if you reference things that are not an instantiator, and also the instantiator helps you to understand how to structure your lens a little bit. Let's go back to our diagram. The thing is, the instantiator, as I mentioned, really helps you to understand what you actually need for building your lens. It's kind of a one-to-one, in my opinion. It makes you think and just think for a second to say, what do I actually need for this lens to work? For example, if you think about Kamehameha, you might just think about line, right? Something like you need to sync something across knee and you need to sync a line. But the truth is that you just need to sync points of the line. And another tricky thing you might go through that I went through is that line usually has a line start and line end points to create a line. But actually here, the lines is between two start points. But one start point is going to be my local start point, and one end point is going to be your remote start points. So that's something that you might just like right on immediately understand, and just gives you a little bit of an understanding how you should think in terms of connected lenses. Because once you know it, it's very easy. Once you don't know it, there is a little bit of that mind-bending moment, which you're like, oh, wait a second, but a line is a hand point. How do you find the midpoint? So on. So let's take a look at the prefabs that are synced across our session. There is the player object, so it's basically my head and your head. Then there is a left hand and right hand object, and then there is a line start and line mid. So once again, you need to, because in this case we're mirroring things, so what I can see you, but you can see me, the object that needs to be synced are not doubled. You don't need to sync like player 2 had, that would be so much, right? That would be not scalable, not sustainable. That doesn't make a lot of sense. You need to think in terms of, oh, one player in my application, what do they need? And that is going to be for each player automatically, and I'm gonna understand what mine and was yours just because of ownership. So understand that again. As you can see here, head pose, left hand, right hand, my start point and my mid point. So I'm getting just this part of the diagram. I'm just getting the player 1 part of the diagram. I'm not caring about player 2 because it's going to be a repetition of it, just with the ownership, which is not ownership of player 1. So it's going to be the ownership of player 2. So this is something that just makes you click for a second. And the instantiator, I think that really makes you think in those terms, because you're like, what do I have to instantiate in the session? So once again, player object manager, we saw the relationship, we reference the instantiator, we reference our object prefab that has a controller, and so on. Let's go for the hand object manager. So besides on logs and things like that, what we have here is still the same thing. It's really the same thing. There is a reference to the instantiator, and then there is a reference to our left and our right hand. So once again, relationship, manager, controller, this is the hands. And then we have the instantiator that holds also the left and the right prefab. So you see how scalable and repetitive is the pattern. Then from here, you move forward and you do all of the crazy stuff, but that you can see how it's intuitive if you think in those steps. So this is a question for you. If you did this for the head pose, if you did this for your hands, what are you going to be needed for the line? So for the line, what you will need is a line start and a line mid, because right? So if we take a look in here, we see line mid. Not casual, the fact that these two colors are the same, because I forgot or I didn't add the fact that to say if that's not player 0, change color to something else. In fact, you notice that all of these colors are shared beside the lines, and I tell you why. You see that the lines have different colors. That's also not a casual thing, because actually we have two different line 3D, which are local reference, which have different materials. And those these two different lines are local objects, so they belong, of course, of my local session. I'm just updating them differently from whatever I get from the cloud. So this is something that, once again, a little mind bending if this is first time, but understand the fact that you have just local references that are synced across the cloud. You're not multiplying, you're not trying to see all of the players in your space, you're just syncing stuff. So let's take a look at the Energy Beam Manager. The Energy Beam Manager has a reference again to the instantiator, a reference to the line start prefab, a reference to the line midpoint prefab, and so on. You might think now, well, but why don't I have the line ending here? How do I find the midpoint? Once again, mind-bending moment, or you maybe already understood everything, just skip ahead. But the reason why is that actually you have the ending of the line, and that is the line start, because you're actually instantiating this twice. You're referencing twice. You're referencing yours, and you're referencing the one of the player that also have a line start. So it's already the line start of your remote player. It's already in the scene. You don't need another reference to go there and just add that line. Then for making things more visible, I also added these references here, which instead of just doing this under the hood, I wanted really to make things clear to you in the scene. And these are all of the local references, which will be moved to give you that final experience that then you see on the device. But once again, these are local entities. So all you will need to see is like your line to start locally. Here's what I want to say. So you will have first line, so the line 3D1 is going to be the line that goes from start local to mid local. And then the line 2 is going to be from start remote to mid local in this case. So that's all you need for your local session. The other thing that I want to talk about is a little bit the scripting. So how do we script all of this stuff, right? And also how do we test? Because one thing is trying on device and one thing is trying on the Lens Studio environment. I recommend always to take a shot. If you have a person with you, I recommend to test it directly with building up from this pattern. But I understand that maybe you don't want to constantly build stuff. So you can also activate the testing mode or trying things in the editor. And usually the testing mode, what it does, instead of reference things like your hands or your head as a camera, it just references dummy objects that you might already have in the scene. So that is going to be helpful for you just to have a cube to understand something like that. You already have the testing mode in all these scripts, so it's already included in the samples, so you can just use that and understand how it works. Now we're going to go through all of the pattern player object controller and player object manager, which is really like the basics of understanding all of the rest of the things that are in this. Let's take a look at the player object manager. So let's dig into some codes to understand what's going on. The binomial controller manager, we mentioned it before, is something very common across all of what is happening. So if we understand this unit of relation between controller and manager, I guess we have a chance to understand almost all the project, right? So the player object manager reference the instantiator, reference an object prefab, and then has a private my player object, which is a controller, which is something that works together with the manager and is also attached to the object prefab that we are going to instantiate. So why are we doing this? First of all, so this is going to help you to understand what I'm saying and put it in context. We need to claim the ownership and understand what's the local and what's the remote object, because actually both the application that are part of player layer 2, they're just instantiating an object, and this object needs to belong to someone. It needs to belong to you or it needs to belong to me. In the case of the tic-tac-toe game, the logic that was behind there was just one object, and that object belongs to you or belongs to me. So kind of similar thinking behind this. We're actually instantiating a lot more object, we're just not instantiating one. But when we instantiate this object, we need to claim ownership. So in this case, or not claim, more than claim ownership, understand if it's actually the object of us, like our local object and not our remote object. So it's very important to understand that, to make that distinction. So here you will see that if you're a Unity developer, you probably appreciate the fact that there is a wait, start, and update. In the first part, on awake, you just bind that start method. So there is not really much to do. This is a pattern that you find in every other utility. Then on start, we wait for the session controller and the instantiator to be ready. And when they both are ready, we instantiate a player object. So we just instantiate a prefab, which has a session controller attached. That's it. We don't do anything. We just don't do anything else. The instantiate player object manager is actually down here. And you can see the description is saying instantiate the player object for the local user. This is called when the session is ready and instantiation is ready. So whenever this happens, the instantiator, which we referenced before and also has the same prefab that we referenced here, is going to instantiate this player object prefab. So we covered everything, right? We covered all of this. But what is actually subscribe in this case? So subscribe is just a method that takes as an argument player object controller, which is this entity that we have here. So we have entity player object controller, and it says whatever is this player object controller here is going to be the one that belongs to the script. So you're just saying this is going equal to describe it. And also an additional thing we do, we just have an update event, and then we bind this update. So we bind this player object on update. Let's check out what happened on the controller, because we're not going to be able to understand this if we don't understand actually what's going on the controller. So on the controller, we have multiple things happening, but not too much. We have a reference, of course, to the player object manager, which we can reference directly actually from the prefab if something is in the scene, which I believe this is different from Unity because you need to reference when things are instantiated. Instead, here you can just reference in the prefab. And when this is, if you go in Lens Studio and you go in the player object, which has a controller, it's in here, you will see that this controller has actually the reference to the player object manager. Then we have a lot of private reference. We have a SyncEntity, which that's what we need for syncing things. We have a camera transform, which is the final provider that will allow us to understand the position of our head pose. Then we have the transform, which is the scene object get transformed. Then we have a previous position. Then we have an app just to understand if we want to keep things rotated parallel position in a certain way. Then on update, we actually do some tethering. So that's why whenever you saw the video, there was a little bit of detachment from the cube to my head, so you actually could see it. And this tethering is constantly updating a position, basically 0, -50, which meaning that is X and Y 0 and -50 in this and that. So it's actually going forward from your head pose of 50 centimeters. And then we get a sync entity from the sync transform that is already on the scene object. So we actually get this, which is, once again, I go through this because once you understand them all. So we are in player object controller and we are getting the sync transform. Then we also get the scene object get child 0 enabled true. So if you ever have an object under here, the player object, we just enable it. So that's it. We're not adding any storage property. So this is just an example for you if you want to add a storage property, but we actually are not making use of storage properties in this very simple example. And then we have the sync entity. This is very specific of the sync it. We are notifying on ready. And if this sync entity is actually existing, so getting the start position, so we are getting the start position of this object itself. So this is running on the object itself. And then we are just assigning basically a position. And then we are just saying that we are enabling the player object content. If we have it, this is good practice. This is very good practice because you have actually an object in here which doesn't have anything. It's just a cube. So this is really what's going on. Parent is doing everything, and then the object under it is doing things. And you can do anything on that object. You can change material, you can do stuff when you get here. And then we have finally our player object subscribe. This we are calling the subscription of this. So this object, this controller, because the subscribe actually takes a controller as an argument. So we're just subscribing literally this class. And what we're doing here, we say my player object is equal to player object. So we're just, all we're doing here, we're just saying the player object that I saved, that I stored privately, is actually the one that just subscribed. And then we create an event, which is the event, and then we bind it on the update. Why we do this? Because we want to constantly sync things. So let's see what happens. On update, my player object on update is the player object controller. We're binding this again, which is the tether object. So we're moving the position. So there is a little bit of back and forth, but I hope that everything makes sense. Once again, you're going to wait. Step 1, wait for the session controller and the instantiator to be ready. Then we just drop something in the scene. This on the scene has this object that we dropped on the scene actually has a controller which is connected to our manager that was already in the scene. Then there is some logic, right, for subscribing to our manager and keep that controller being up to date. Also, here there is a clear distinction between local and remote player, because one thing is just instantiating object in the scene. One thing is actually understanding what's my object and what's the object of the other person or other players. So this is very simple, but if you scale it up, this will apply to many other things. Now that we understood actually how to synchronize an object of my local player and remote player, so we can see each other in the scene, everything else comes pretty naturally, because the hand is really the same thing repeated twice. And instead of getting this reference of the camera, which we had in this script, so if you go in the controller, we actually get the camera transform, right? Where is it that we get the camera transform is set as a board camera fan provider get instance get transform. So this is actually what we get for understanding the head pose. For the hands is really the same. We're just getting literally the hands, like left or right, we're gonna have, but we are understanding that through tracking heads. So once again, this is similar, taking advantage of some more utilities like SIK, but once again, we get it again, we get the pawn center from SIK, we understand if it's left or right, so you will need to set up that in your prefab. So if you go actually in the hand object in here, and you go in the left hand object, you will see that you have hand type, string, left or right. And the thinking behind this, it's all the same. So we have an object manager, the object manager waits that everything is ready, calls the instantiator instantiates an object, the manager makes the object theirs, and then keeps updating that object. Energy beam manager, same thing again, but we're doing it the sign with a start and a midpoint of the line. And I want to do something here that is going to make you understand a lot more probably. Alright, multiplayer, space our line. See, very good here. You see 3 dots, 1, 2, and then probably this is the beginning here, which I'm clicking through. And then we're going to do this, and we're going to check the scene hierarchy. Why is everything under enable already? Because the instantiator actually had that rule, like instantiate just under this parent. So very important. And let's take a look at this. So if everything we said makes sense, we should have a line start, which is the local start line. So we see that there is this position here. And then we have a line start, which is the remote start line. So we have this. So the local midpoint will be the midpoint between these two coordinates. A little bit weird at first, and it's kind of a little bit, if you want to call it, it's a mistake, but not really a mistake. The thing is, if you wonder why the line mid that is updated is only 1 and not 2, you will see that this is always at 0. In fact, if you just go around, this is the line mid that is not updating. There's only one that is updating, which is the one in the middle of the 2 lines. You can see the one there in the background that is moving actually with the line. That's the one that it's been updated. The reason is, if you just double click on the line mid, you will see that this does not really have a sync curve entity or a controller manager behavior. This really does not have, just that line mid does not really need to be synchronized because it's been guessed by the start and the end of a line. So you actually don't need to synchronize this, you just need to put it in the scene and just update it. And the mid line is the same for both because the line is the same. So the space is the same, and so one is enough. Alright guys, so this was the end of this pretty long tutorial. I hope that things are a lot more clear now, and at least you got a good start of what working with connected lenses means. Just briefly looking at these samples, I hope you start to recognize some patterns of how we did certain things and how these things that we did could apply to this tutorials. These tutorials are all optimized for those things, so you can imagine that this is a sync entity between two players, this is another sync entity between two players, and probably the raycast here is the hit point of the raycast is actually the position it is synchronized across devices. This shared sync control is like sharing all of the settings parameters across the network, so on. So if you're interested in connected lenses, I think this is a great addition to your lenses. One thing that you should know also is that if you make a lens and you not necessarily want it to be a multiplayer lens, you can also play in single mode and you don't need to build twice the application, you can only build once. So it's actually pretty cool that you can just get that kind of flexibility out of the box. Thank you for following this connected lens tutorial. Please comment below if you want to see more specific topics that you're interested in. I'm very curious to know what would you like to build the spectacles. Peace.